Welcome to our channel, fellow travelers of the cosmos. Today, we embark on a thrilling expedition to explore the most mysterious, the most captivating, the most downright weird events that grace the canvas of our night sky. From the ethereal glow of the auroras to the fleeting brilliance of meteors, we'll uncover the cosmic ballet that unfolds above us. Buckle up, because we're about to unravel the science behind these celestial marvels, revealing the awe-inspiring forces that paint our universe. Let's kick things off with the rock stars of the night sky, the auroras. Imagine curtains of shimmering light dancing across the heavens in vibrant hues of green, purple, and red. These celestial ballets, known as the aurora borealis in the north and aurora australis in the south, are born from a celestial dance between our sun and Earth's magnetic field. The sun constantly emits a stream of charged particles called the solar wind. When these particles collide with Earth's magnetic field, they get channeled towards the poles, exciting atoms in our atmosphere and causing them to release light. Oxygen gives us green and red, while nitrogen throws a little blue and purple into the mix. But hey, the night sky has more tricks up its sleeve than just auroras. What about those electrifying displays of raw power we call lightning? Lightning is a massive spark of electricity, leaping between clouds or between a cloud and the ground, releasing all that stored up energy in a blinding flash. Now let's talk about those fleeting streaks of light that make us gasp in wonder and quickly make a wish. Meteors, or as they're often called, shooting stars. Despite their name, they have nothing to do with stars. Meteors are actually small pieces of space debris, often no bigger than a grain of sand, that burn up in Earth's atmosphere. As they hurtle through the air at incredible speeds, friction with the atmosphere causes them to heat up and vaporize, creating that characteristic streak of light. Meteor showers occur when Earth passes through a stream of debris left behind by a comet or asteroid. The Perseids in August, the Leonids in November, the Geminids in December. Each meteor shower is associated with a specific comet or asteroid and occurs at roughly the same time each year. So mark your calendars, folks, because witnessing a meteor shower is a truly humbling and awe-inspiring experience. Have you ever looked up at the sun or moon and noticed a faint luminous ring around it? That, my friends, is a halo, an optical phenomenon that's as beautiful as it is scientifically fascinating. Halos form when sunlight or moonlight is refracted by ice crystals in Earth's atmosphere. The most common type of halo is the 22-degree halo, which appears as a ring with a radius of about 22 degrees around the sun or moon. And speaking of rainbows, let's not forget their close cousin, Irisation. Irisation, also known as cloud iridescence, is a colorful optical phenomenon that occurs in clouds. This mesmerizing display is caused by diffraction, the bending and spreading of light waves as they pass through small openings or around the edges of obstacles. So the next time you're gazing at a cloudy sky, keep your eyes peeled for these fleeting but beautiful optical illusions. Chapter 4: Nighttime Glow. Let's dive into the magical realm of bioluminescence, where living organisms light up the night with their own internally generated glow. From fireflies blinking in a summer meadow to deep-sea creatures illuminating the abyssal depths, bioluminescence is a testament to the incredible diversity and ingenuity of life on Earth. Bioluminescence is the result of a chemical reaction within an organism's body, involving a light-emitting molecule called luciferin and an enzyme called luciferase. When these two substances interact in the presence of oxygen, a burst of light is produced. Now, bioluminescence isn't just about putting on a pretty light show, it serves a variety of important ecological functions. For some creatures, it's a form of camouflage, helping them blend in with their surroundings or confuse predators. And in the dark depths of the ocean, where sunlight can't penetrate, bioluminescence is a lifeline, allowing creatures to communicate, navigate, and even hunt. Chapter 5: Mysterious Light Sightings in History. From ancient tales of celestial beings to modern UFO sightings, the history of humanity is rife with accounts of mysterious aerial phenomena that have yet to be fully explained. One of the most famous examples is the Foo Fighters phenomenon reported by pilots during World War II. Pilots from both Allied and Axis forces described seeing strange, glowing objects following their aircraft, often performing seemingly impossible maneuvers. While many of these mysterious light sightings can likely be attributed to natural phenomena, misidentifications, or hoaxes, there remain a handful of cases that continue to defy explanation. Chapter 6. Volcanic Eruptions and the Sky. Volcanic eruptions are some of the most awe-inspiring and destructive forces on Earth, capable of reshaping landscapes and impacting the planet's climate for years to come. When a volcano erupts, it releases massive amounts of gases and particles into the atmosphere. These volcanic emissions, particularly sulfur dioxide, can have a dramatic effect on the way sunlight interacts with our atmosphere, leading to some truly stunning visual displays. One of the most striking phenomena is volcanic twilight, or volcanic sunsets. When volcanic aerosols are present, they scatter the sunlight, creating vibrant hues of orange, red, and purple that paint the sky in a breathtaking spectacle. These volcanic sunsets can be so vivid and long-lasting that they've been known to inspire artists and poets for centuries. Chapter 7. Let's return to the mesmerizing dance of the auroras, those celestial ballets that grace the high-latitude skies. Earth's magnetic field acts like a giant shield, protecting us from the constant bombardment of charged particles streaming from the sun. But here's the catch. Our planet's magnetic field isn't perfectly uniform. It's weaker at the poles, which is why the auroras are most commonly seen in the high-latitude regions around the Arctic and Antarctic. Charged particles from the sun are guided by Earth's magnetic field lines towards the poles, where they collide with atoms in our atmosphere, creating those mesmerizing displays of light. The color of the aurora depends on the type of atom being excited by the solar particles. Oxygen emits green and red light, while nitrogen produces blue and purple hues. Chapter 8. Types of rainbows. Rainbows, those iconic arcs of color that grace the sky after a storm, have captured the imaginations of cultures around the world for centuries. Rainbows form when sunlight is refracted or bent as it passes through water droplets in the air. As the light enters a water droplet, it's separated into its different wavelengths, which correspond to different colors. Sometimes we see a fainter secondary rainbow arcing above the primary rainbow. This is called a double rainbow, and it's formed when sunlight is reflected twice inside each water droplet. The colors in a double rainbow are also reversed compared to the primary rainbow, with red on the inside and violet on the outside. Then there are supernumerary rainbows, which appear as a series of faint, extra bands of color inside the primary rainbow. Chapter 9. Nighttime glowing clouds. Imagine this. The sun is set, the stars are starting to twinkle, and then, high above the horizon, you notice wispy, luminous clouds shimmering with an otherworldly glow. These aren't your average, everyday clouds. These are Noctilucent clouds, also known as polar mesospheric clouds, and they're as mysterious as they are beautiful. Noctilucent clouds form in the mesosphere, the coldest layer of Earth's atmosphere, which lies about 50 to 85 kilometers above the surface. Scientists believe that Noctilucent clouds are made up of tiny ice crystals that form around meteoric dust. These shimmering clouds are essentially made of space dust. As meteors burn up in Earth's atmosphere, they leave behind a trail of tiny particles. These particles act as nuclei for ice crystals to form around in the frigid temperatures of the mesosphere. Chapter 10. Celestial events in historical records. Throughout history, humans have gazed up at the cosmos with a mixture of awe, wonder, and sometimes a touch of fear. One of the most famous celestial events in recorded history is the supernova of 1054 AD. This massive stellar explosion observed by Chinese astronomers was so bright that it was visible in broad daylight for 23 days. The remnant of this supernova is the Crab Nebula. Then there's Halley's Comet, a celestial visitor that has graced our skies every 76 years or so for millennia. These are just a few examples of the countless celestial events that have captivated and inspired humanity throughout history. From the dazzling auroras to the fleeting beauty of rainbows, we've explored a spectrum of celestial wonders that grace our sky. Each phenomenon, a testament to the intricate dance of physics, chemistry, and sometimes a touch of cosmic mystery. If this journey through the weird, the wonderful, and the downright awe-inspiring has ignited your curiosity, give this video a thumbs up and subscribe to our channel for more explorations of the universe and its many marvels.